Hi everyone, welcome to this section next part of the part 4 video of the digital logic circuits. In this particular video we are going to discuss about bubble gates, universal gate, NAND and NOR gates, as well as XNOR gate. After that we are going to see the complete discussion related to the overall all gates truth table at the one particular point on one particular page. We will get all the gates truth tables. This is about our this video plan. Now we are moving to the bubble gates. So first of all, you understand bubble is nothing but a knot complementation. So bubble gate is the one whose input are knotted or inverted. So for example, your AND gate inputs are connected to the bubble, that is a NOT gate. So what about the output you may expect? See here, A bar and then B bar. Here C is equal to A bar into B bar. That will be equivalent. Apply the De Morgan's. It will be, just apply the De Morgan's theorem. A bar A plus B whole bar. That means which is a gate here? This is a NOR gate. So my conclusion, one of the important point here in the examination also, last year question paper it is there, the bubble AND gate is equivalent to NOR gate. Bubble AND gate is equivalent to NOR gate. Maximum members are thinking that NOT gate connected to AND gate, it will be NAND gate. Okay, but the thing here, in case of bubble gate, it is bubbles are connected at the input terminals. Whenever it is connected at the input terminals, it is a not a NAND gate, it is a NOR gate. Got my point? Next, coming to the this is a representation of bubble gates for AND. In case of OR gate is connected to the bubbles, what will happen? We'll see. So this is the OR gate. Sorry, there is no bubble here. Okay, this is the OR gate. It is A, it is B, both are connected to the bubbles. Okay, NOT gate. So now A bar and then B bar. Coming to here, at the output A bar plus B bar. This apply the De Morgan's, you will get plus is converted into dot AB bar. So this is a NAND gate. That means here bubble OR gate is equivalent to the dash gate. NAND gate is also important. So this is about the NAND and NOR gates connected to bubble. Next we are moving to the NOR gate. So NOR gate is a combination of NOT and OR gate. NOR gate is a combination of NOT and OR gate. NOT gate can be connected. See, it can be made out of the OR gate connecting an inverter at the output. Very important. Inverter connected at the output terminals, it is act as a NOR gate. So look at here. This is the OR gate and then connected to NOT, you will get the NOR gate. So NOR, in the examination you may expect the question, the NOR gate is a combination of, they will give us different options, AND gate plus OR gate, AND gate plus NOT gate, OR gate plus NOT gate, none of the above. OR gate plus NOT gate is nothing but a NOR gate. Look at the truth table. The NOR gate function C is equal to A plus B whole bar. For example, A is equal to 0. For example, B is equal to 0. 0 plus 0, 0. 0 bar 1. That means that both the inputs are 0. Output may 1. See here, truth table. Okay, second case. For example, A is equal to 1, B is equal to 1. That means 1 plus 1 whole bar. That will be 1 whole bar. It is equal to 0. That means that whenever both the inputs are 1, output will be 0. Remaining cases, any one input is 0, 0 plus 1, 0 plus 1, 0, 1, 1 bar 0. That means that it is also get 0. So the final conclusion here, whenever both the inputs are 1, output will be 0. Whenever both any one input is 1 or 0, output will be 0. Whenever both the inputs are 0, then only we'll get the output is 1. That is about the NOR gate. Clear? So this is a relay about the NOR gate. How exactly it is working, see. So this relay is connected to the battery, everything. So for example, both are 0, open circuited. So circuit is normally closed and then light will be glow. Whenever both the switches are closed, for example, this relay is attracted, this particular normally closed, it is act as a normally open. Whenever it is normally open, circuit is open circuited here. Whenever circuit is open circuited, this battery is disconnected to the lamp will not glow. Okay, 0. So in the similar case, any one input is also high, for example. In that particular case, this is a low. In that case also, circuit will be closed, normally open, that is relay is attracted this particular normally closed circuit. Then total entire circuit will be disconnected from the supply, will get 0. So whenever both the inputs are open, so it is normally closed, light will be glow. So this is the way the relay is working. Coming to the transistor. So in the examination point of view, they won't ask the working principle, they won't ask the any remaining, they will give directly the circuit. For example, this is circuit is given, identify below circuit is related to which gate. So you are supposed to do that. This is a NOR gate. In the examination you may get confusion, right, because so many circuits we have. So that's why I'm explaining the working. In case of you don't know, if you have forgot about the gates, or if you are confused, just apply what I gave the working principle, then you will get the idea. The truth table of NOR gate, this is a NOR gate, you can identify the answer. That is the reason why I'm explaining the working principle. Now for example, here both are 0, right? Whenever both are 0, both are open circuited, output will get 1. Yes or no? Because what amount of 5 volt appears across this output? Now both the inputs are 1, both are closed switch short circuited, that means 5 volt is grounded, it will get 0. Any one input is 1, any one input is 1, one transistor is conducted, other transistor is open, even though the 5 volt is connected to conducted transistor. So that means output is 0. So finally both the inputs are 1, you will get the 1. Any input is 0 or both the inputs are 0, will get 1. Any input is 1 or both the inputs are 1, you will get 0. That is about the NOR gate. Okay. Now this particular NOR gate can act as a universal gate. That means that it can realize by using NOR gate with the help of the AND gate, NOT gate and NAND AND gate. So AND gate, OR gate and NOT gate, 3 gates can be constructed with the help of the only one NOR gate. That is a speciality here. That's why NOR gate is a universal gate. I will prove that why it is a NOR gate is a universal gate. Okay. First you will see NOR gate as a NOT gate first of all. So NOT gate is nothing but if you are given the input is 0, you will get 1, output is 1. Input is 1, output will get 0. So in this case, I am taking the NOR gate and then both the inputs are connected together. Okay. So I gave A, and then this A and A are connected to, this is a NOR, right? So NOR gate output you may expected A plus A bar, because both the inputs are same, A and A. So A plus A is A bar. Then you are given the input is 1, A, output is A bar. This is the NOR gate whenever both the inputs are connected. So this is the representation for NOR gate. So NOT gate as a using NOR gate. This is operated as a NOT gate. This NOR gate operated as a NOR gate. Everyone is clear? Now we are moving to the OR gate. OR gate act as a NOT gate. OR gate, for example, in this particular case, up to here, this is an OR gate. Which circuit is connected to eliminate this particular ball, then it act as OR gate or not. That's why you are connected to NOT gate. When I connected to NOT gate, so C is equal to A plus B plus whole bar and whole bar. These both the bars are get cancelled, we will get the A plus B. A plus B is nothing but OR gate. This is a way universal gate. Now my question here, replace this NOT gate with NOR. Then you will get the OR gate with the help of the NOR gate is completed. Then you will see that particular case. Here up to here, this is the up to here this is a NAND gate, NOR gate, that is converted into NOT gate, right? You will get the A plus B. This is a universal gate for the NOR gate. Two NOR gates are required to construct the OR gate. Two NOR gates are required to construct the OR gate. In the examination, minimum gates are required to construct the NOR gate. Only NOR gates. Two NOR gates are required. Next, coming to the third AND gate. AND gate, this NOR gate inputs, you are connected two bubbles. Okay, so two bubbles are connected. You will get A bar and B. That means that C is equal to A plus A bar plus B whole bar. So that will be equivalent to A into B double bar get cancel. What will get? A into B. A into B is nothing but a AND gate. Okay, clear? So that AND gate is a representation here, AND gate. So now my question here, just replace this 2 with help of the NOR gate, then you will get the universal gate or not. So that's why, see here. Okay, so these two bubbles are replaced by, these two NOR gates are replaced by NOR gate, act as a NOT gate, and then this is the circuit. Now this is a universal gate for NAND, as a NOR gate, act as a AND gate. Clear? So this is about the different type of gates. Using only NOR gate, you can construct the UNI gate. Okay, coming to the NAND gate. So in case of NAND gate, it is a combination of NOT and AND gate. So the output of the AND gate connected NOT gate will get the NOR gate, NAND gate, sorry. So NAND gate output is, AB bar. So AB bar is a NAND gate output. Because AND gate output is AB, we are connecting NOT gate, that's why bar will come. So we will get AB bar here. Here AB. Okay. Now we will see the truth table for NAND gate. So AB bar is a logic. Now both are 0. 0 into 0, 0 bar. So 0 bar is 1. Both the inputs are 0, output will 1. Next, second case, 0, 1 bar. 0 into 1, 0. 0 bar, 1. That means any input is 1, output will be 1. Next, come back to the, both the inputs are 1. 1 into 1 whole bar, 1 bar, it is 0. Both the inputs are 0, output will be 0. This is the condition. So for NAND gate, both the inputs are 0, output will be 0. Remaining all other case, output will be 1. That is truth table for the NAND gate. This is a relay diagram for NAND gate. In that case, you are connected two series switches. Both are 1. It is a closed circuit. Then this relay is attracted. Circuit will be opened from the supply. It will be 0. That's why both are 1. It will be 0. Remaining all other cases normally closed, because any one switch is open circuited. Whenever open circuit, this relay is not activated, you will get the output will be 1. All other cases. Okay. Next, we are moving to the equivalent circuit diagram. So in the examination, you may expect it, they will give the different diagrams. Identify that this particular circuit is which gate. This particular circuit is NAND gate. It is a simple, the up to here, this is a what gate? AND gate. So working principle of AND gate. AND gate output is connected to NOT gate. Then you will get the NAND gate. So let us see how exactly. For example, both are 0. These two diodes are reverse bias. Whenever two diodes are reverse bias, what about output will be present? Here 0. Both are 0, output will be 0. That 0 is connected to NAND gate, output will be 1. Whenever both the inputs are 0, we will get the output is 1. Next, remaining cases, any input is 1, the diode is conducted. That means this particular 5 volt is dropped across here. You will get 1 here. That means that particular 1 is connected to inverter. It will get 0. Will get 0. So whenever whenever both the inputs are 0, then only you will get, whenever both the inputs are 1, then only will get 0. Okay, that logic I am going to explain. 1 and 1, for example. Both are 1, total entire output will get it is conducted, you will get 0 here. Okay, so that means that when you will get 0, that means it is 1. Both the inputs are 1, you will get output is 1, that is converted to NOT gate, you will get 0. Okay, that is a working, it is a simple. Then we are moving to the NAND gate is a universal gate. So yes, two NAND gate, two inputs are connected together, and then NAND A into A bar, we will get this is the NOT gate. NAND, this is the representation. Coming to the AND gate, NAND gate, two NAND gates connected together, here AB, A bar, this bar you need to disconnect it, you need to eliminate it to connect the one more NOT gate using as a NAND, then you will get the AND gate. So here also two NAND gates connected as input, A bar and B bar. So here NOT gate, NAND gate, A, B, already it is bar and whole bar, that will be equivalent to A bar, double bar plus B double bar, that both the bars are get cancelled, we will get A plus B, that is a NAND gate. Coming to that is a universal gate explanation. Okay, in the examination they will ask the question, what are the universal gates? NAND and NOR, both are universal gate, no other gates, don't get confused, only NAND and NOR are only universal gate. Coming to the XNOR gate, so XNOR gate is a simple, just XOR gate, we are connected to the NOT gate, we will get the NOR gate, XNOR gate. So that is a bar is present. You know, in this particular case, truth table, we will see both the inputs are 0 or both the inputs are 1, you will get the 1. Remaining all other cases, you will get the 0. So XNOR gate will be A, B plus A bar, B bar. This is a XNOR gate logic. Apply that logic, you will get the truth table. You will see. In case of A plus B, A exclusive B is equal to A bar B plus B bar A. That is, you know, XNOR gate. It is a XNOR gate. That is a exclusive OR gate. So coming to here, AB 0 into 0 0. Here A bar 1 into 1 1. 0 plus 1 1. Okay, you will get 1. Coming to here. Here 1 into 1, here 1 bar, it is 0, it is 1, the output will be 1. Yes, both the inputs are 0 or outputs are 0, both the inputs are 0 or inputs are 1, you will get the output is 1. Remaining cases, any one input is 0, output will become a 0. See, 0 into 1 plus 0 bar into 1 bar, 0 into 1, 0, here 0, here 1 0, 0 into 1 0, 0 plus 0 0. So in all the cases you will get 0. That is the XOR. You need to remember in this particular, this is the logic for XOR gate, A B plus A bar B. Coming to the logic gates at glance, and that means all logic gates truth table I will provide it here. So for OR gate A plus B, okay, this is a truth table. Both the inputs are 0, then only it is output is 0. Remaining all other cases, you will get the output is 1. Coming to the AND gate, both the inputs are 1, then only you will get 1. Remaining all other cases, you will get 0. Next, NOT gate, input is 0, output is 1, output is 0, input is 1, output is 0. So NOT gate. Coming to the exclusive OR gate, you know, in the exclusive OR gate, both the inputs are different, then only output will be 1. Remaining all other cases, output will be, that means output inputs are same, output will get 0, that is call it as a exclusive OR gate. Exclusive OR gate is also called as a comparator. It compares the output, both the inputs are different, compare both the inputs are different, output will be 1, that is called it as a comparator. Next, NOR gate. In the NOR gate A plus B bar, this is the symbol. In the NOR gate case, both the inputs are 0, then only output is 1. Remaining all other cases, output is 0. Next, NAND gate. In the NAND gate, you know, AB bar is equal to C. Both the inputs are 1, output is 0. Remaining all other cases, output will be 1. Finally, XNOR gate, just now we discussed, both the inputs are 0 or both the inputs are 1, then you will get the 1. Remaining all other cases, output will be 0. So this is all about logic gates. So everyone prepare this particular chapter thoroughly, because you might be expected 2 to 3 questions from the logic gate. This is a very important. And then finally, in the next video, lecture number 5, we are going to discuss about the half adder, full adder, half subtractor and full subtractor, and the parallel adder. These 5 topics are left. We are going to update it in the next video, and then in the video of lecture number 5. Thank you.